What I am very certain about is that Bitcoin mining is going to drive innovation. When phones and consumer electronics have so far driven innovation in computer chips, that's what has given us chips that have transistors down to 2 nanometer size. That's the incentives around that were we're trying to make them smaller, we're trying to have them air cooled, we're trying to use less electricity. That's actually something that we have in common with Bitcoin mining. But in Bitcoin mining, the incentives are slightly different because the chips don't need to be small. We don't need to build 2 nanometer chips. And there are already companies like Samsung that are trying to do different architectures of chips that are not just in 2 dimensions, for example, that are building up in 3 dimensions, or that have just a wraparound gate, or you can start playing with different architectures, maybe make a bigger one. It doesn't matter when a Bitcoin miner is a large machine, because you can just build a warehouse in the middle of Texas and have it mined there. Bitcoin is, the incentive structure is set up in a way that it self-balances all of those attack vectors very quickly. So it's, if anything, it would be a very short-lived attack span, and then immediately would be put online. And that's the case for something like quantum computing as well.
BTC Prague, and once again, fellow Bitcoiner.
Yes.
Elly Pembroke.
Mm-hmm.
You're not affiliated with anybody, is that correct?
No, I'm just a free actor, a free person. In the, just like Bitcoiners should be.
And you just ran into Mark. And Mark, what comes to your mind when you think of a fellow Bitcoiner from the States actually traveling here for BTC Prague?
Yeah, when I met Ellie, it was pretty surprising because normally women in the Bitcoin space are not so technical. But she surprised me with all his insight, and it was so fascinating because she's into, let's say, mining or proof of work. She was even into mining or proof of work before she was a Bitcoiner. And normally you come in the Bitcoin space and then you see, oh, there are Bitcoin miners and they use chips, they use ASICs. And she was like doing this before she even discovered Bitcoin. And maybe you can give us a little introduction how you came in the Bitcoin space and what you did before the Bitcoin space and why this technical side is so interesting and what especially is interesting you.
Yeah, absolutely. My background is in semiconductor science. I innovated in the chip space before Bitcoin existed, because I was interested in making consumer electronics cheaper, better, more efficient. And so I pursued a PhD in making field effect transistors out of graphene. And graphene is just a single layer of carbon atoms. It has very interesting electrical properties, and it can make the switching of the ones and zeros, which are the field effect transistors on a chip, more efficient, cheaper, smaller, especially. Then after I completed my work on graphene field effect transistors, that's when Bitcoin was invented and proof of work was invented with Hashcash. And then that just drew me in, because here is a technology that incentivizes for chips and field effect transistors to be even more energy efficient, because each individual miner is trying to spend as little energy as possible to calculate as many hashes as possible. Now, while every individual miner is trying to conserve energy, as a whole, the Bitcoin community consumes more and more electricity, because we're trying to put in more and more lottery tickets to try to win the winning bid. So that's how, even though we're trying to bring miners online that are more and more efficient, that are not just, back when I first started mining, when I first got interested in Bitcoin, you could mine with your CPU on your computer. You could just, in the Bitcoin client, you could just toggle a switch and it would mine Bitcoin with your CPU. We don't do that anymore. We don't need to use all-purpose chips that are able to run videos and stream Netflix. to compute hashes. Hashes are a much simpler computation to do. So now we can, the industry has come around to create chips specifically for Bitcoin mining. They're called ASICs. ASIC stands for Application Specific Integrated Circuit, the application being Bitcoin mining.
Wow. There we had it. Amazing. Learning from you right away. And guys, if you're out there, maybe have one question. I've heard one earlier, which a lot of people want to know. Just share it down below or ask questions. All the time, I think you're open to answering. The one thing is, you talked about the innovation.
Yes.
And the speed with the graphene chips.
Mm-hmm.
What is it about that makes it so much faster? Mm-hmm. And how far is the development right now?
Okay, so this is still in the prototyping stage. This is not a commercially available product. But the cool thing about graphene is that the difference between the switch, so in a field effect transistor, you're not using a physical switch to turn something on and off or to create the ones and zeros, but you're using an electrical pulse, an electrical signal, a gating voltage to create the a state in which less electricity passes through or more electricity passes through. Now you have a cutoff where you say, okay, below this amount, it's going to be a 0, and above this amount, it's going to be a 1. If you can push the 1 to a lower amperage, you use less electricity and you conserve electricity. That's where you get the savings from. And the on-off ratio, so between the lowest possible and the high energy state, that's the difference between those. If you can create with as little change in the gate voltage as possible, you create as much of a on and off separation. That's where you get the energy savings from. So that's why graphene is so interesting, because it has a very high on-off ratio.
So now I have a very interesting question. Maybe this is a bit of a stupid question,
That's okay.
But is it possible that maybe at some point we get a breakthrough in chip producing, that, for example, the hash rate of this new chip generation is so extraordinarily more powerful and it's so much more energy efficient that this actually is a tech for Bitcoin, because maybe you can get pretty much hash rate with almost no energy cost, because the new generation of chips is now so efficient. Is this possible, or is it like a steady?
So the question is very similar to a question I get very often: is quantum computing going to destroy Bitcoin? And it's a very similar question in that, is the new generation of chips going to destroy Bitcoin? Because, you know, if nation states or the wrong hands get their hands on this technology first, they can mine first and then they can. So the thing is that, yes, maybe if with a lot of capital expenditure, you can build enough of a mining army that you obliterate all of the hash power that's already online. But it will only help you for one cycle, and then basically the financial incentive is there that good actors will also jump on that bandwagon, will also buy the new technology, and will be able to bring hash rate online. So Bitcoin is, the incentive structure is set up in a way that it self-balances all of those attack vectors very quickly. So it's, if anything, it would be a very short-lived attack span, and then immediately would be put online. And that's the case for something like quantum computing as well. As soon as you have an encryption scheme that is better than elliptic curve, you can, you have that attack vector for one cycle, and then immediately Bitcoin can then, someone's going to submit a BIP, and the new encryption scheme is going to be used for Bitcoin.
So you were talking outside, and you were talking about this paradoxum, and
Yes.
and it's about efficiency, and maybe you can just sum up, because I forgot the name about the paradoxum.
Yes.
I can't remember it, and it was so well explained. So can you just explain it again for me, please?
Yes, absolutely. I already started talking about it a little bit when I talked about efficiency and how energy efficiency is really the one incentive that is driving the chip innovation in Bitcoin ASICs. So this paradox that you mentioned is called the Jevons paradox. Jevons paradox does not just apply to Bitcoin mining, it applies to any process that consumes a resource. So that can be a car that consumes gasoline, it can be a Bitcoin miner that consumes electricity. And if you make that process more efficient, so that means that that particular process will consume less of the resource that you're putting in. And in that particular instance, less of the resource is used. But because less of the resource is used, more market actors get access to that process and that resource. More people will start driving cars. And so globally, more of the resource is going to be used, the more efficient you make that process. So if we're trying to make cars more efficient, we're going to have more gasoline use. If we're trying to make Bitcoin mining more efficient, we're going to have more hash rate brought online. We're going to use more electricity.
Interesting. Patrick, do you have anything else to add?
I like that. I like that. You're going deep into the thought process, and you're going deep into the technical point of view as well. I'm just curious, when will we have like the first graphene chip or the first graphic acid miner out there? Is there a time frame you can share with us? What do you think?
There isn't really a time frame, and I'm not certain that graphene is going to be the next generation of chips. What I am very certain about is that Bitcoin mining is going to drive innovation. When phones and consumer electronics have so far driven innovation in computer chips, that's what has given us chips that have transistors down to 2 nanometer size. That's the incentives around that we're trying to make them smaller, we're trying to have them air cooled, we're trying to use less electricity. That's actually something that we have in common with Bitcoin mining. But in Bitcoin mining, the incentives are slightly different because the chips don't need to be small. We don't need to build 2 nanometer chips. And there are already companies like Samsung that are trying to do different architectures of chips that are not just in 2 dimensions, for example, that are building up in 3 dimensions, or that have just a wraparound gate, or you can start playing with different architectures, maybe make a bigger one. It doesn't matter when a Bitcoin miner is a large machine, because you can just build a warehouse in the middle of Texas and have it mined there. So whenever you, in any innovative process, in any optimization problem, whenever you're trying to model an optimization problem, you have the problem of local and global minima. You have, or maxima. And when you don't change the boundary conditions of your innovation, you will get stuck in one local minimum and you will engineer the heck out of it. And that's where we've come with 2 nanometer nodes. We've stuck to silicon. We've reached kind of the end of Moore's law. We are just making silicon smaller and smaller and smaller, and it's great. Like, the innovation in that space, in lithography, is bordering magic. It's fantastic. But we will never get out of that local minimum of optimizing silicon if we never change the boundary conditions, if we only ever try to innovate for consumer electronics. But if we have now different boundary conditions, if we can make bigger gates, if we can use immersion cooling, we can use different architectures for chips, that's when we can get out of a local minimum and maybe try to find a global minimum in optimization and really innovate in this space and not just optimize.
Wow, that's really baffling. Very, very interesting. what you're sharing with us here today. And I want to thank you so much.
I have one more
Mark,
question.
You got one more?
Yeah, one.
Right, let's go for it.
One last question. So
Yes.
right now, lots of chips are produced in China. So there is some type of centralization. We don't want to talk about if this is a problem or not, because I don't think it's a problem. I guess you maybe too, or maybe you can give your view on it. The more interesting question for me is why are mostly the chips produced in China? Is it because the resources are there, or is it because they have the knowledge? Is it or do you have to build the infrastructure to build the chips? So why is it that mostly?
Yes. So I can help you understand it that way, maybe. To build a chip fab facility has a very, very large startup cost. In order to be at the very cutting edge of the smallest nodes, you have to have a lithography process that has actually been developed in the Netherlands, and it's just the one lithography machine is $150 million. There is no small companies that are going to get into this industry. It has to be an economy of scale, or else you won't be able to compete. So what I know is that people do try to compete, and Intel has actually dabbled in trying to make Bitcoin miners as well. Their specs weren't quite as good as the AND miners, but they haven't been able to justify producing it because there's just not enough demand for it. So even though more and more hash rate is being put online, hash rate is always at an all-time high. If we can, we will put more hash rate online. The market absorbs new generation miners very, very quickly. But the market itself is not large enough yet to justify a diverse multiple sources of chips. So there are a few on the market, but it's still whoever can whoever can spit out the most hashes for as little electricity as possible will basically consume the entire market.
And is actually chip producing, so let's go a bit off topic, so let's leave this Bitcoin topic. Is it actually a concern for national security? Because nowadays so much things are, you need chips everywhere. And if you have a chip shortage, actually your country is not running anymore. So is this a concern of national security?
I wouldn't put it as a concern for national security, but it is a concern for the local economy. So a lot of, when we experienced the chip shortage, there was a lot of automobile manufacturers that weren't able to produce, and there's a lot of European economies, American economies do depend on chips to be incorporated in their products. But when it comes to national security, there's always redistribution that can happen, and I feel like that's whenever there's a shortage, they need chips for national security, they will prioritize that, and then the economy will suffer for it. So they will sacrifice the economy basically for the national security.
Wow. Let me ask you one thing. If people, listeners, viewers want to reach out to you,
Yes.
where can they find you, and what's the easiest way to contact you? Are you willing to answer other questions for them as well?
I'm happy to answer questions. You can find me on Twitter. I'm Elly Pembroke on Twitter, and you can find me. I've given interviews on YouTube and other platforms before. Please reach out. I'm happy to answer questions.
So thank you so much. If you want to find Elly Pembroke, you just heard it. Find her online on Twitter. Give her a shout out. Let her know what you are interested in. And I want to thank you so much for being here, for jumping on.
Thank you for interviewing me. Not enough people are talking about semiconductors in the Bitcoin space, so I appreciate you giving me the platform and the opportunity to talk about it. It's super fun, and innovation just gives you hope for the future, right? Like it restores your faith in humanity a little bit, so I'm happy to be a part of that.
Thank you.
Thank you. Thanks a lot.
Thanks.